Hello everyone. Now I'm going to talk about problem 10 for homework 8. Show that if the normal process is wide sense stationary, then it is strict sense stationary. It is a normal process for the beginning. So we consider the joint probability density function of n random variables. The fx, we consider x1, x2 to xn, as well as T1, T2 until Tn. It should be something like this. And now we have to know what is the C here. The C is the expectation of x minus eta. So this eta is the expectation of xt. We know that xt is wide sense stationary, so the expectation is a constant. We use eta to represent it, and we write it out to get to know more details about it. From 1 to n. So this part and this part, from here to here, all of them are equal to n, are equal to eta, and times, we also copy it and pass it, because they are the transform of it. So use RT to define it. And RT1 minus eta square, T1 Tn minus eta square, actually it equals to this thing. And it is WSS. So for WSS, it's RT1 T2 equals R minus, and it is just R0. This is also R0. Now we can rewrite it as CT t1 minus t2, t1 minus t3, and so on until tn minus 1 minus tn, just minus them one by one. So it is Cti minus Tj. We just use this to simplify it. For I not equal to j and ij are from 1 to n. That is, this part can be represented by actually this part in this function can be represented by ti minus tj, and the definitions are the same. Now we consider how to prove the strict sense stationary. For strict sense stationary, we can check the definitions as if for a real stochastic process, if it is stationary in strict sense, the statistics is not affected by a shift on the time axis, which means that two processes, for example, xt and xt plus epsilon, they have the same statistics for any epsilon. So now we want to know the when t turns to t1 plus epsilon until tn plus epsilon, it equals to ti plus epsilon minus tj plus epsilon for this definition, which means that we can simplify this part into ti minus tj. So this is just from t1 to tn. Okay, so the definition of strict sense stationary is satisfied. Oh, I realized that I misunderstood the definition. So we say that a real stochastic process xt is stationary in strict sense if its status is not affected by a shift on the time axis. So this is proved for any epsilon and for any n, any t. That's all for this problem. Thank you for your listening.